The area bounded by the graphs y equals the root of 2 minus x squared and x plus root 2 minus 1 y equals root 2 equals one of these four options. Okay, so my first thought here is to just, well, first of all, we're going to plot this to figure out, exactly what the region of interest looks like. Certainly based on the numerical answers given, we'll probably have to actually work out an integral of some sort. So I note that in the first expression, because we have y is equal to the root of 2 minus x squared, this puts limits on x. X has to be between plus and minus root 2. And this is going to form the upper part of a circle. And of course, the second expression will give us a straight line. Just a rough sketch of the circle. And if I rewrite the formula for the straight line, well, maybe we can do this more intelligently by using a couple specific values. When y is equal to 0, x is equal to root 2. So the straight line goes through this point. And when y is equal to 1, no, let me just rewrite this. So there's a straight line which goes something like this. Where exactly is the intercept? When x is equal to 0, y is equal to root 2 over root 2 minus 1. So that's something greater than 1. So what I want to find now is that intersection point. What would be the best way to do this? Maybe just setting the two values of y equal to each other. So I have y is equal to 2 minus x squared under root. And I also have y is equal to root 2 over root 2 minus 1 minus x over root 2 minus 1. If these are equal, this is a lot messier than I expected, but should get us there. I guess, we don't need to do this by inspection. When x is equal to 1, these are equal. If I set x equal to 1, there's a common denominator here. And by setting x equal to 1, the numerator and denominator are equal. And so this whole right-hand side becomes 1. And when I set x to 1 here, I have the root of 1. Okay, so this point is at 1, 1. There was no need to go through everything else there. So on the one hand, I'm tempted to just write out an integral and compute this, right? We'll be integrating from 1 to root 2. We'll integrate that function, and then we'll integrate the other function and just take a difference. Yeah, I think that's probably the best thing to do. Based on what's written here so far, I suspect the answer is B, because it looks like we have a mixture of trigonometric and polynomial integrands. But I'm just going to go through the computation and see what happens. Great. So I get something which is equal to none of the answers available. So I don't know what I've done wrong. And, Jesus. I'm tempted to just start again. I've obviously made a stupid mistake somewhere, and it could be as far back as the beginning. I'm going to completely start again here. Okay, now that I draw this picture, I see a much easier way of doing this. The area, oh wait, no, I don't. Okay, I'm going to do this purely geometrically. The area we're looking for is this shaded region. But what we can recognize here is that if I take that shaded region and that shaded region, the blue region and the pink region add up to the same thing as the yellow region. So how do I want to write this? So that plus that is equal to that. And I also know that this plus the square is equal to the quarter circle. That region plus this square is equal to the quarter circle. And we can, of course, also easily find the area of that triangle. So the radius of the circle is root 2. So pi r squared is 2 pi. We divide by 4 because we have a quarter circle. And so this tells us that the yellow area is pi over 2 minus 1. And the blue area, It's just a triangle, base times height over 2. The height is 1, the base is root 2 minus 1. It's that. And so the area we actually want is pi over 2 minus 1 minus root 2 minus 1 over 2. I think I must have another arithmetic mistake somewhere. Yeah. I forgot to divide by 2 here. That number. So it should be pi over 2 minus 1 divided by 2. Yeah, so my original instinct was correct that the second option is the right one, and I mean it's sort of showing evidence of both trigonometric values and or areas of a circle in the pi over 4, and you know, the area under a straight line where there's a lot of square root 2 in the formula for the straight line. So that's why it looks like the mix of the two types of quantities, one with pi and one with root 2, seemed like it was probably going to be the correct answer. I don't know where my mistake was in the first time the first method going through this. This one was clearly a lot easier. Once I drew that horizontal line, it became a bit more clear that this can be done purely geometrically. Yeah, I don't know where my mistake was earlier, and it ended up being a much messier integral than I expected. But anyway, I might spend some time trying to find out where my mistake was, but the answer to this one is B. Thanks for watching.